Welcome to Pong Academy, where learning is free.
This is a shorter version of my presentation at the 2023 Healthcare Packaging Consortium virtual meeting, on April 21, 2023. The presentation title is Lessons Learned from a Design of CBU Packaging Laboratory Building.
This presentation will discuss floor layout and equipment locations, ceiling height, testing under a desired environmental condition, heat rejection of environmental chamber, and illumination.
This slide shows a 20-plus year history of CBU packaging. The idea of having a packaging building was in the early 2000s. At that time, it was envisioned a partnership with various companies under the Packaging Institute. The building is a simple one-story building with open space for lab equipment. Then CBU received a $3 million grant from the Assisi Foundation of Memphis for engineering lab equipment and facility upgrade. Part of the grant was used to acquire a few basic pieces of packaging equipment during 2003 to 2006. A small packaging lab was born. Together with additional equipment donated by FedEx Packaging Lab, CBU Packaging Lab went for lab certification. Since 2009, it has then become a certified commercial lab certified by the International Safe Transit Association. In 2010, the Healthcare Packaging Consortium was established. The consortium has evolved over time. It hosted its in-person meetings before the pandemic. Since the pandemic, the meetings have become virtual. This allows participants beyond Memphis. A new packaging lab building is under construction. It is expected to be ready in early 2024. The new building together with new equipment will allow CBU to establish a new ISTA-certified thermal testing lab, in addition to the existing ISTA-certified transport testing lab.
This slide shows a 3D rendering of the new packaging lab with a floor plan. The new entrance will lead into the existing engineering lab building. The building was designed by Fleming Architects. Linkus Construction is currently building it. It gives about 4,000 square feet of lab space, which is about double of what we currently have. We are grateful to the generosity of Mr. Dick Gadomski for donating $4.2 million for the new building and equipment. Thank you.
The groundbreaking ceremony occurred on February 14, 2023. More information can be found under News on CBU website and from an article on the Memphis Business Journal.
This floor layout shows two packaging labs, divided by a walkway from the entrance into the existing lobby of Benilde Hall. The new building is considered an addition to the existing engineering lab building. The new building code requires a gender-neutral restroom, which does not exist in the existing building. The north part of the hallway is for the thermal and material lab, while the south part of the hallway is for the distributing lab. The distribution lab is home of our existing ISTA-certified transport testing lab. The thermal and material lab is home of our future ISTA-certified thermal testing lab. An equipment moving pathway was planned. It connects the two labs together, with a short crossing over the hallway. This allows the moving of equipment from delivery area south of the distribution lab, to the thermal and material lab. Tables and chairs on this equipment pathway can be easily moved out of the way when needed. At least 3 feet around equipment is provided for equipment operations. And at least 2 foot space is provided from a wall.
This slide shows equipment locations in the thermal and material lab. 2 new pieces of equipment are highlighted. The one labeled with number 7 is a portable microclimate chamber. It is a small environmental chamber, which is perfect for material research using small specimens. Another new piece is a 64 cubic foot reach-in environmental chamber. Together with the existing 32 cubic foot chamber, we will be able to handle multiple projects in the future. The existing altitude chamber is also useful for thermal studies, when humidity is not required. A new rack for corrugated sheets is placed near the Kongsberg cutting table. It will allow corrugated sheets to lie flat without bending. Other pieces are existing equipment, including Kongsberg cutting table and shock machine. Small tabletop equipment will be on benches around the lab.
This slide shows the equipment locations of the distribution lab. There are several new pieces including a large vibration table, large drop tester, walk-in environmental chamber, incline impact tester, and large compression table. Other existing equipment in this lab includes a small vibration table, small drop tester, and a small compression table. There are lockers along the walls and an office in the lower left of the lab.
There will be 3 new environmental chambers. The microclimate chamber is small and portable. It is perfect for material research. The 64 cubic foot chamber allows us to handle more packaged products than the current 32 cubic foot model. The walk-in chamber will allow us to place 2 pallet loads in it for conditioning. Please note that all chambers are from Cincinnati Sub-Zero. This makes it more convenient in terms of maintenance, calibration, and repair.
There will be 4 new pieces of distribution testing. All of them replace the old or existing ones. As with the chamber, all new pieces will be from the same vendor, in this case, Lansmont.
Ceiling height is controlled by the tallest equipment. In our case, the walk-in chamber is the tallest. The chamber itself is 10 feet and 4 inches tall. However, there is a condenser on the top, which is another 20 inches or 1.67 feet. For maintenance, the chamber need another at least 5 feet clearance to the roof. These add up to 17 feet. The ceiling height was designed for 18 feet and 4 inches. Some locations the clearance will be less due to the roof joists. However, roof joists are spaced out and give room for maintenance.
It is desirable to perform a test under a desired environmental condition. Most of the time, packaged products are conditioned at a desired environmental condition in an environmental chamber. Then, it is tested in the ambient lab condition after the conditioning. It takes time for humidity to change. However, temperature can change fairly quickly. With the walk-in environmental chamber, tabletop equipment can be put on rollable benches. The equipment can be rolled into the walk-in chamber for testing. We will be able to test under -22 dP 104 Fahrenheit and relative humidity from 20% to 95%. Tests on these tabletop equipment are of short duration. Thus, it should be safe for the test operators. Also, we plan to use stainless steel bench. A rubber pad placing underneath the equipment would prevent electronic shock or short circuit.
Heat rejection is the heat released from an environmental chamber into the lab during operation. If it is significant, it can affect the temperature in the lab. An experiment was set up in an existing polymer and packaging lab, where the 32 cubic foot chamber is located. 3 temperature data loggers or recorders were placed in 3 locations, near the chamber, near the lab entrance, and on a corner far away from the chamber.
This slide shows results for 2 cases, one case with a very low temperature at -29°F, and another case at a very high temperature at 300°F. In both cases, the chamber started in the afternoon and ran for about a day. The change in the average temperature are very little. The graph simply followed the ambient room temperature, which was lower during the night. It should be noted that more heat rejection occurs when the chamber is operating under low temperature. The chamber pulls out the heat in the chamber to keep interior space of the chamber cold. This heat is released into the air. One can feel warmer near the chamber.
The worst situation we have run for our lab customers was 29°F for 72 hours. Thus, we ran a case for that condition. The graph on this slide shows the temperature increased near the chamber for the first 60 minutes. This gave about 2° rise in 60 minutes. The heat rejection was then calculated to be 424 BTUs per hour. This is based on the data collected near the chamber. It is not a real representation of the entire lab. This concludes that there is no problem with heat rejection. Also, both new labs have bigger volume. Thus, heat can dissipate out into the big room. Its effect on HVAC will be very minimal.
Illuminance or light intensity is measured in foot candle or FC. The electrical engineer on the design team designed the light intensity for an average of almost 80 FC in both labs. This is in the range of recommended light intensity for indoor working space.
This slide lists typical light intensities. For examples, 10,000 FC for full sunlight and 200 FC for visually intensive work.
A light intensity meter was acquired. This slide shows different foot candles or FC under various ambient conditions. When more light is needed, it is more economical to get additional light from headlight instead of designing the lab space with higher intensity.
In conclusions, involving in the design of this lab building gives opportunities to learn something new. Designing a new lab building is more challenging than an office building due to equipment. For examples, many pieces of packaging equipment are big. Power supplies are not consistent, such as 110 vac, 208 vac, 240 vac, etc. Some need compressed air and some need water. Moving existing equipment to the new facility has to be planned ahead. And installing new equipment, we need to be flexible. You may not get what you want. Others considerations include budgetary constraint and time consuming. It is also important to get the contractor involved early on.